Hello again, my name is Irwin Donis-Gonzalez. I am an Associate Professor of Cooperative Extension and Post-Harvest Engineering in the Department of Biological and Agricultural Engineering, or BAE, and the Post-Harvest Research and Extension Center Co-Director. Today, I am at one of my favorite places at UC Davis, the BAE Manufacturing Shop. As an engineer, the shop is a pivotal facility that enables me to develop new equipment and sensors to offer technological solutions for post-harvest applications. When I joined the BAE department and the Post-Harvest Center, I never imagined that I would have the pleasure of working on such a diverse set of projects. One aspect that impressed me the most is that engineering or technological solutions can be completely different, even with plants of the same genus. For example, sweet cherries and almonds are species of trees from the genus Prunus. However, their fruits are treated entirely different during the post-harvest phase. During the post-harvest phase, many products are conveyed dry through conveyor belts to sort, clean, and package them, ultimately cooling them to the desired storage level. In California, sweet cherries are washed, conveyed, and commercially cooled with water, known as hydrocooling. This prompted a statewide project where we evaluated the effect of water on the quality of sweet cherries, especially on its impact on cracking or splitting. We found that if surface water is not immediately removed after hydrocooling, it will be absorbed by the cherries and increase the pressure inside the cherries, causing them to bulge and rupture. Therefore, many sweet cherry packagers now use engineering solutions, such as air knives, to remove this moisture. On the other hand, almonds are not cooled but dried in windrows on the orchard ground. Unfortunately, almonds are prone to pest and human pathogen infestation during drying. It affects timely irrigation and involves harvest steps such as picking and sweeping, which generate significant and undesirable dust. To address these challenges, we developed and evaluated the performance of a heated stockpile dryer to dehydrate almonds in a stockpile. By using these methods, almond growers now have an alternative option that allows them to timely irrigate and eliminates the existing harvest dust-generating steps, such as picking and sweeping. These are a couple of examples that allow us at the Post-Harvest Research and Extension Center to provide relevant information to local, national, and international growers, shippers, marketers, carriers, distributors, retailers, processors, and consumers of horticultural products through our impactful post-harvest research and extension programs.